Okay, so the next section we're talking about friction again. And this is quite a big difference with year 12. We're going to talk about how to calculate the maximum frictional force. So a word you're going to see coming up a lot now is the word rough instead of smooth. So smooth means there's no friction, rough means there is. And it sort of depends on two things, okay? So the two things are actually reflected in the equation we're going to use. So the maximum frictional force, and it's not just friction, okay? It's the maximum frictional force is given by mu. So mu is a number that you'll often be given or you have to find out. And it pretty much operates as a constant in a question. It's a number that links to the material that you're talking about. So some materials, like if you're talking about the contact of ice and ice, has a very small number. If you're talking about something that's very rough, so look, there we go, we've got rubber on concrete, you'll have a big number, which will approach 1 for Maths A level. So that's the first thing. The other thing is it's about the reaction force of the particle. Now, remember that doesn't always stay the same. It depends on not just the mass of an object and therefore its weight. It also depends on the other forces that are in the picture. So this will all make a bit more sense when we have a look at how it works in a minute. But for now, we're going to say that the maximum frictional force is given by mu multiplied by r, which is the same r you've seen before. Right. On the board, we've got two questions we're going to have a look at. So my turn and your turn. Let's have a go. So the block's 10 kilograms, so we've got 10g, okay? And there's a rough horizontal surface. So this is here because it's telling you that there should be friction in the question. The block is being pulled by an inextensible rope with tension T. Given that the block is on the point of sliding, in each case, find these things here. So the phrase "the point of sliding" might sort of not sound very important, but it is. It tells you that that friction is at its maximum, okay? Which means that you can use it as an equation with mu r, which is what we saw on the slide before. So F over here, I'm actually going to write that as mu r. I just find it more useful, okay? So find the normal reaction of the surface on the block. So that's this one here. And then we actually need to find out what mu is in this question. Okay, so the usual steps that we've been doing before have been thinking about forces one way and another. So we're not going to do parallel and perpendicular here because look at the arrows that are already in the question. Vertical, vertical, horizontal. So we're going to break this one up because then it will go with the rest of the diagram. So T is 21, so this is 21 sine 30 then. And then this one here must be 21 cos 30. And I'm going to make my equations, but before I jump in, I'll make a vertical equation first because it's about the normal reaction. So let's do that one first. So let's do a vertical one. So all of the forces up, which is R, and this one here, 21 cos 30, sorry, 21 sine 30, must be equal to all of the forces down. So that's 10g. Why? Well, because it's staying in contact with the table. So the resultant force is 0, so I could say up equals down. 10g is a number, 21 sine 30 is a number. So there you go. You can see now how I can get the first part, and I'll reveal that for you in just a moment. How about the coefficient of friction? Well, if you look at the picture, it's a horizontal arrow. So there's no way of me talking about it unless I make something about the horizontal direction. Now it says it's on the point of sliding, so it means it's about to move, it's about to accelerate, but it's not accelerating. So I can do the same thing that I just did. I can do like a left equals right one. So the force to the left is mu r, and that's it. The force to the right is 21 cos 30, and that's it. The thing is, I already know what r is from the previous question, so I could just substitute that one in. So let's take a look at that. So in the first part of the question, we got r, which ends up being 87.5. And then for the next part, we sort of do what we did before. You would divide by r in this case, okay? So to get this on its own at the end, you would just divide it by it. And you know that number from part A. So you get 0.2 and so on and so on. Pause the video, have a quick go at the one on the right-hand side. Start by resolving the diagonal force. Make an equation for the vertical direction. Make an equation for the left and right direction too. Once you've done that, you should get the following numbers. Okay, so notice how they've written it slightly differently to how I did it again. So I wrote it like this, but can you see they've just moved that to the other side? So it's the same thing. Okay, and this question really is exactly the same question, just with the different numbers. Okay, so same meanings, same context, and so on. So our next question: a particle of mass 5 kilograms is pulled along a rough, so that means there is friction, a rough horizontal surface by a force of 20 newtons. The coefficient of friction, in other words, mu, is 0.2. What's the magnitude of the frictional force? Well, friction, the maximum friction is given by mu r. Okay, and it will be maximum friction because the thing is moving. It says it's pulled along, so it is moving. So in other words, this question is saying to you, what is the value for mu r? Now, it's not 20, yeah, or it's not necessarily 20. You can't just assume that. So what we're going to have to do, because we know what mu is, we're going to have to find r, and then we can find mu r. So if we have our diagram, we can see that r will be equal to 5g, because up will be equal to down, okay, because it's staying in contact with the floor. So mu r is going to be 0.2 times 5g, all right, which is just 1g, or g. Now, what's the acceleration of the particle? Well, when we know that things are accelerating, we want to use F equals ma. So what's the resultant force? The resultant force to the right is 20 minus mu r. Mu r is just g, so 20 minus g equals m. M is 5, and that's a. So divide both sides by 5, and you'll get your answer. Okay, so that will end up being 2 meters per second squared. Just to move on, like the easy mistake to make there would be to assume that mu r and 20 are equal. But you would only do that if the thing were not accelerating. Next question. So we've got an inclined plane now. So a particle of mass 2 kilograms is sliding down a rough slope at 30 degrees of the horizontal. Given that the acceleration is this, find the coefficient of friction. Okay, so we're going to sort of go backwards in this question. Best thing to do to start with is draw the plane, draw the particle, draw all of the forces, and just work from there. So hopefully this diagram is within reach. R, because it's on a plane. 2g is the weight. Remember, we break that up, opposite and adjacent. Then I'm going to get rid of that. We're told that it's sliding down, so that's why we can make that one like that. The friction is there because it says it's rough, and because it's going down, it must act against that. And 5g, I think that's just a mistake. I don't think that's meant to be there. Okay, so we've got this diagram. Now, how do we talk about mu and acceleration stuff at the same time? So my instinct here would be that we want to start talking about parallel to the slope, and we take it from there. So I'm going to make down the positive direction. Is there anything that works in that direction? Yes. 2g sine 30. So I'm making F equals MA now, F equals MA equation. So 2g sine 30 is going down. Anything else going down? No, but mu r is going up. Well, it's acting up. Okay, so those are my forces done, and then that will be equal to MA. So MA, the mass is 2, and the acceleration is 1. So that's looking pretty good. Sine 30 is a half. Sine 30 and 2 cancel out. So if I just clean that up a little bit, I can get g minus mu r equals 2. The problem is I don't know what r is. So as we said earlier, it's generally a good idea to do a perpendicular equation as well. So let's do that. So with a perpendicular equation, r, which is that one, is going to be equal to 2g cos 30. They are the only perpendicular forces involved. Cos 30 is root 3 over 2, and they'll cancel. So r will be equal to just root 3g. And this r is the same as this r here. Okay, so you've now got all the pieces that you need. So g minus root 3g mu equals 2. And you can just rearrange this one yourselves. Okay, remember g is just a number. So we've only got one letter there. So that's for you to solve. And you get 0.46. And you're going to encounter answers where mu is between 0 and 1, typically. So there's a question on the board. It looks very wordy. It has a few different ideas from across the chapter. I'd encourage you just to pause it and have a go before we look together. Okay, so let's go through this. So R, alpha, tan alpha. Yeah, so do you remember that when we have these situations, what we do is we sketch triangle. So 3, 4, 5. If you don't know what I'm doing at the moment, you need to go back to video 5b. So that means that sine alpha is going to be 3/5, and cos alpha will be 4/5, and we'll be using these numbers in a moment. What else is going on here? So it's 2 kilograms down. Depending on how confident you are, you may be able to just sketch this one in straight away. So I'm going to call this 2g cos alpha and 2g sine alpha. Because you'll always have these 3 parts, okay, for these kind of questions. Interesting that they say, just a second, I'm just having a quick look that I put cos alpha here. Right, I'll tell you what, let's just read through this carefully. So a box of mass 2 kilograms is held in equilibrium. Okay, that's quite important. On a fixed rough inclined plane by a rope. So that looks like it's a tension. This line here just doesn't really mean anything. The rope lies in a vertical plane containing a line of greater slope of the inclined plane. It just means it's drawn as it is. So alpha, okay, so this angle and this angle are actually different to each other. So this is not cos alpha, is it? This is cos 30. And this one will be 30 as well. Okay, because this one that you would normally have in there would be 30. It's we need this, we still need this, it's for this angle up here, okay? The coefficient of friction is 1/3. That's an important piece of information. It's on the point of slipping up the plane. Right, that's very important as well. It tells me that if the thing's about to go up, that friction then should be drawn that way. Okay, because it always acts against the direction that it's moving or that it's about to move. Particle, inextensible string, find the tension. Okay, so they do want that one there. Right, let's finish off this force diagram then. So we want everything to be perpendicular and parallel. So this one then is going to be t cos alpha, and this one here is going to be t sine alpha. And now I'll get rid of that. So 1, 2, 3, 4, 5, 6. I've got 6 forces on my diagram, which is what you should have as well. When there's friction involved, you're pretty much always going to need to do a perpendicular equation and a parallel equation. Because I was told it's in equilibrium and it's on the point of moving. If it's on the point of moving, that means it's not moving. So I'm going to do these left equals right, up equals down equation. I'm going to do some of those equations of motion. So let's do, first of all, let's resolve it in a perpendicular way. So R, which is acting away. Any other forces acting away? Yes. So there's t sine alpha. So plus t sine alpha. So the forces acting away must be equal to the forces acting into it, which is that one there. So that's equal to 2g cos 30. And you can do some work on cleaning this one up. So R equals sine alpha is 3/5. So that's not an equal sign, that's a plus sign. So R plus 3/5 t. Cos 30 is root 3 over 2, which cancels with the 2, so it's root 3g. So this equation's got R and t in it. Okay, now let's do parallel. I'm going to do up the slope as positive. So, well, as the left-hand side, I mean. So t cos alpha is going up the slope. Anything else going up the slope? No. 2 forces going down the slope. So this force will be equal to those 2 forces. So mu r plus 2g sine 30. Do some cleaning up on that. Cos alpha is 4/5. So 4/5 t is equal to mu. Yep, I've got the value for mu. So that's a third r plus sine 30 is a half. So that's just all going to turn to g. So can you see now? I've got 2 equations there. The g, remember g is just a number. They both got r and t in them. Okay, so I'm not going to do the step on the slides, but what I would do if I were you is I would get them so they both have r and t on the same side. So I'd take this one away to the left-hand side, and then I would use my simultaneous equation solver on my calculator. Okay, and I'm finding the t value, so I don't need to find the r value. And if you do that, well, what I'm talking about there is eliminating f and r. So what I'm talking about, the simultaneous equation step is the same as that step there. And then you should end up with 15.5. Okay, it says a lot of marks on here. I'm not sure it's really 8 marks on the new spec, but it really is still quite a lot of marks. Okay, you will get lots and lots of credit for these steps here. Okay, you'll get credit for the idea of separating them, resolving the components, using them together, and you'll also get credit for the accuracy of doing that as well. So quite a few marks available here if you understand the key ideas. And then we go, we're on to 5C. So we've said that maximum friction, which can be when something is moving or when something is on the point of moving, is given by mu times r. Resolving parallel and perpendicular again. And the second point there really is just about making sure you read the question very carefully. So we'll come back to this a little bit in chapter 7, but time now to do lots of practice at these questions.